Alrighty, I got myself a nice cup of tea and let's continue. So we have this beautiful triangle and let's talk about texturing in Sokol. And to draw a texture on the screen, we probably need to draw a quote, like if we want to draw a sprite or something. So let's actually do this. Quad, as you know, consists of two triangles, so we need 4 vertices. So let's just change our topology a little bit. Let's add a new vertex, of course, to our vertex buffer, and let's just have a different coordinate. So let's have our top left, then maybe top right, which would be 0.3, right? At the top. Then we would have bottom left, which would be this, right? And that would go down. And then bottom right, which is, it's like this, right? And if we draw that, this will be just one part of it, which is not exactly what we wanted, because we want to draw 4 vertices. If we do this in a draw call, this will not work actually, because the graphic driver the graphics card can only draw in triangles. So we could duplicate our vertices here, but of course the proper way is to use something called index buffer to just specify the graphics card, like which indices of which vertices to draw at for which primitive, for which triangle. And for that we need to create a vertex buffer. So let's have a variable for it. I'm sorry, not vertex buffer, but index buffer. And this index buffer is actually created exactly like the vertex buffer, with SG make buffer and all this stuff. All this stuff, by the way, I kind of want to maybe extract in a nice function called SG range, because it's a Sokol graphics range. It will be a proc that returns this SG range, right? And it would return this structure that it needs from a slice of some type. So let's have it as a slice of generic type, parameterized, and this will be the same, except that instead vertices we would use S, and S here and S here. So now if we pass make buffer to the data, to the vertices, that should be hopefully working well. Yes, so hopefully we can make our code a bit more compact now and create an index buffer to draw a quote easily. So for indices we usually use unsigned ints, because it's just numbers of vertices in the vertex buffer. So let's use a 60-bit int and say for the first triangle we want to draw the top left to the top right to the bottom left, right? And for the second triangle, let's start with bottom left to the top right to the bottom right. So of course this should be indices, because copy paste, of course, that's what we all like. And this should be an index buffer. And one thing that we need to pass here to make it an actual index buffer and not something else, not a vertex buffer, because those are different things in the graphics APIs. So we need to say that its type is an index buffer. So now we have 2 buffers. We should probably not to forget to, of course, clean it up. Our index buffer, yes, please autocomplete. And now what we need to say to Sokol graphics and subsequently our underlying graphics API that we want to use the index buffer. And for that we need to specify it in the pipeline, of course, and the parameter that handles this is index type. So by default it's none, so we don't use the index buffer, but we want to say uint16 because that's what we use. You could also use a uint32, but that would obviously take more space and probably be a bit worse for performance, and this is enough for our current purpose. So you can draw up to 65, max int 16 number of vertices, which is more than enough to draw a few quads for us. And now we want to, like this number, the number of elements will be the number of indices to draw, and we want to draw all of them, so that would be 6 or maybe len of vertices, but since we don't really store the length anywhere, we just hard-code it here for now, so that would be 6. And if we do it like this, nothing will happen. And let's see why. Because we don't bind it. We specify the vertex buffer, we specify to the pipeline that we want to use it, but we don't bind it. And I'm actually confused why we don't get any validation warnings, but I have a suspicion that it's due to us not specifying the debug argument here. That would enable all this validation stuff that will just fail horribly. So you see validation, apply bindings pipeline defines index rendering, but no index buffer provided. So this is exactly what was happening. So we can say index buffer, our index buffer, and that should be it. Nice. Cool. That's amazing, right? That's great. That's a quote that is drawn using a proper vertex and index buffer technique. And let's try doing something nice with it, like maybe applying some textures. So if we go to each.io, so this I guess something that we don't really need right now. If we go to each.io and choose like game assets textures, we get a ton of stuff here. Let's just download the first one. This looks really cool. Yeah, we can purchase this. I don't really have it, but we can also download the demo. So let's just download it, I guess, to the desktop, and then maybe just extract it to the desktop and see what do we have here. So what do we have here? A bunch of pretty cool textures. Let's take this brick texture, let's just move it here. Oh wow, that worked. Nice. So we have this small texture. It's actually 64 by 64. It's really small, but it doesn't really matter. We can use it. So for that file to be displayed, we need to first load it and then load it into the memory somehow, like parse the PNG file, and then upload it as a texture, or rather as something that is called image in Sokol graphics. So there are two problems here. First, how do we load it? And thankfully C has this amazing header set of libraries called stb, and Odin has a binding to it, thankfully, in the vendor collection stb. Now stb image to be specific, and this will allow us to load the image. So the API is quite simple actually. So let's give us a storage field for our image, so sg image, right? And now we want to load the image from the file. So first we want to load the pixel data, right? So pixels equals stbi load. So currently the IDE support for Odin cannot deal with this construct, so it actually will not show you all the functions that are in this binding, but what we really want is to use this function. So this is called load, and it just expects a file name, which is something that we can just copy paste, right? And then it would return us the size of x and y, right? So let's say w and height of cint, which is i32, and then num channels in file. We don't really care because we can say that we want 4 channels for our color values, which are vector 4. So we will specify, and STB image will be so nice to convert it to the desired format, thankfully. So what we want to know is, of course, width and height, because we will need this data to actually create a Sokol image. So let's say we want to have a pointer to the width and pointer to the height. Then this, I believe we can just use nil for the pointer, and the desired channels is 4 because we are using 4 component colors. So yeah, we can assert that pixels are not nil, so it's loaded. Let's see, it's loaded. Yeah, it's not failing, so it works presumably. And now we have our pixels, so we can actually create an image, which is SG image, make image, I'm sorry, which of course requires a descriptor, and the descriptor is image type, which we can leave as default, width and height, which we just got from the STB. All this stuff is not really something that we don't really care. What we care about is the pixel format, and the pixel format for our pixel data that we just loaded is RGBA8. So it's 4 channels, 8 bits each one of them, so 1 byte, because that's actually what the comment here says, 8 bits per channel interface. So RGB8 is our pixel format of choice for this one, and the other one is image data, which is in a pretty weird format, so let's get to it when we get to it, right? So as I said, we need to specify width, we need to specify height, which we already have, thankfully. Then we need to specify a pixel format. Oh my god, format of, yeah, I'm so used to like this JavaScript-y column object declarations. RGBA8, good. And then we have the data, and the data is a weird 2-dimensional fixed array of, you know, 2D array of range structs. The first array is the cube map face, and since we are not doing a cube map, we only have one face, so that would be 0 element index for the first one. And the second array, dimensions of the mipmap levels, so we don't really use mipmaps, so we will also upload just a single face, a single mipmap. So what we will do here is provide 0 for the first one and the 0 for the second one, and this is range. And here we cannot really use our nice SG range function because that is supposed to work with slices, but we have our pixel data pointer, which we can use as is, so ptr equals pixels, and the size is of course width multiplied by height multiplied by 4, because we have height rows of width columns, and each column is 4 bytes for 4 channels of our color. So size is just like this. Or we could probably just say, no, it's not a slice, so we couldn't say len of this is just a row pointer. And after that we can actually free the image, free the pixels, because we don't really need it anymore in our memory. it will be in the video memory. So let's see if that didn't fail, and that failed because the structure actually needs another layer of fields like this, subimage equals, and now this complains that uint is, well, it's not. Yeah, the uint is what can't assigned? Yeah, we can just say uint. So this is a size t, which is a like platform specific pointer size, which would be 8 bytes, so 64 bits, and this is in 32. So we want to cast it like this, and if we run it like this, so at least it doesn't fail, but we don't really use it right now. And to use it is yet another story. So we have the image, right? It is uploaded as a texture to the video memory, but we need to use it somehow. So firstly, we of course need to use it from the shader. So we need to pass it to the shader. And this is where it gets a little bit complicated, especially if you didn't really work that much with graphics APIs and with GLSL. Like me, for example, I know the basics, but I don't really work with it every day. But I will try to explain as best as I can. And yeah, you guys probably know how this works better than me anyway. So first we need to actually pass our texture as something called uniform, which is not per vertex but per draw call, so just some data. And we need to pass a texture 2D, I believe, of texture. So that will already, I believe, complain. Of course, I'm pressing the run button, but what we actually need to do is to build the Sokol shader. So let's actually take a little bit of destruction and write a build.bat script that will actually do this for now, for the starters, and then run the Odin compiler for us. So Odin build minus debug. Is it everything that I do here? Yeah. And now we can do build.bat instead of whatever we had here, because we have it here. And to be actually nice, we should probably have this. So if the error level of this is not 0, then we probably need to exit from the batch with some non-zero code, and the same here. And maybe also we need to support the so like if we pass the first argument equals run, right, we maybe want to also run our hello Sokol.exe. So what we can do now is try to build it, and it will build also the shader and then the program, and we can also specify run here to actually build and run. So yeah, as you can see, the error here is that it needs a explicit layout qualifier, I believe it's called, which is like at which binding slot we want to bind it. So that would be layout binding 0. So we just want to bind it to the first uniform binding, and that will already work. And now if we take a look at the shader generated code, we will see, are we gonna see this? No, we are not, because it will be actually eliminated because we don't use it. So, but we can actually use it. So what we want is to sample, so to like pick one color from the texture. And for that, first we need something called texture coordinate or UV coordinates, and those are something that we need to pass to the vertex to be interpolated, just like we do with the color. So basically that means that specifies from which point in the texture to pick the color for this vertex, and then it's gonna be interpolated between vertices. So what we are gonna do is to, of course, actually pass it as a vec4 text chord or something. So text chord equals UV. So now it's gonna be interpolated between vertices for each fragment. So now that's gonna be an input here. So we output color and text chord, and we get the color and text chord that will be interpolated by the system. And now we can actually sample the texture. But to sample the texture, we need yet another thingy called sampler. And yeah, the sampler is another uniform. That's why I copy pasted this. That would be sampler, and let's call it just SMP or whatever. And with this, we can finally sampler. So what does the sampler do is it specifies, so the texture contains the data, right? It contains what to sample, and the sampler specifies how to sample. How do we want to interpolate? How do we want to like mix colors from multiple surrounding like pixels? If we want to have a smooth filtering or just choose the nearest pixel color. What if the texture coordinates points outside of the texture? Do we want to repeat the texture or to wrap? This is all what the sampler is concerned about. So, and to sample the texture, we just use a texture function, and we need to pass a sampler to it, sampler 2D to be specific, that takes a texture, and the sampler, I guess it's a configuration. And then the second argument to the texture function is our UV. And finally, we can multiply it by our color, so it will actually use the multiplication-based tinting to the color, so we can actually pass both color and texture coordinate to that. So now, alright, this complains about some stuff, because of course text chord is not vec4 but vec2. And now this complains about some more stuff, which will be undeclared identifier, because this is not UV. Here, this is text chord interpolated coordinate. Now it works on the compilation level for the shader, but it doesn't work in our game because we didn't specify the pipeline layout properly. Thankfully, Sokol is so nice to give us all this information to actually figure out what's going on here. So here it complains that the pipeline has not invalid state because, well, I guess it's not that informative, but we know what's going on here. What we need to provide is, well, first we have a new vertex attribute, which is this UV. So we need to set it up here. Thankfully, we have a generated number for the UV. And this is float 2. So this is one thing that we need to do. And another thing that we need to do is, of course, pass them here in our vertex data structure. That would be UV of vec2. And we just need to specify it like this. So let's say for the top left, we say we get from the top left of the texture, so 0, 0. To the top right, we get from the right left, top right of the texture, so 1, 0, because those coordinates are always normalized, so from 0 to 1. Then we, of course, for the bottom left, we say 0.1, and for the bottom right, we say 0, 1 and 1, so bottom right. And since we have two uniforms, like texture and the sampler, we actually need to create, we already have the texture, which is this image, but we also need to create a sampler. So let's create a sampler, which is SG sampler. And the sampler is something that we can very easily actually create with just some default configuration, which I believe will be I actually don't know what are the defaults, but this is what I was talking about, which filters to use, how to wrap, how to do other stuff. So all the usual texture sampling configuration is here. And we probably should clean up our image and sampler. So destroy image, destroy sampler, and of course this is not index buffer, this is image, this is sampler. So just be a good boys and clean everything up after yourself. So if we do this, it will still, of course, fail horribly, but now the error message is a bit more useful, because it says that the sampler binding is missing and the image binding is missing. So let's fix that. In the rendering function, when we do the draw call, we do the binding, right? We bind the vertex buffer, we bind the index buffer, but we don't bind any images or samplers, and we can easily do just that here. So we can say please images, and we can say 0 because we know that it's 0, but actually shader provides us with this nice bin slot constants. So we can say instead of 0 we can say image.text g-image. So that's how we bind the image. And for the sampler we of course do the same, but with the sampler, and maybe I shouldn't have copy pasted it. That's images and samplers, and this is SMP because the first is image or SMP, and the second one corresponds to these names. So if we ever change this or remove this, the code will be regenerated with different constants, and we will have a compilation warning, compilation error, in fact, for this. Anyway, enough talking, let's take a look. You see, it's so beautiful, it's so nice, it uses colors and the texture. So now we can just set all the colors in our init function to white. Maybe we can just set all the ones here. Yeah, maybe we should use a constant for that, so let's just do that, like color white, or just white, we don't really care. That would be a SG color, which is a useful structure that I showed before. Here it's exactly 4F32, and we can just say, yeah, just tint it with white, which means that it will not be tinted at all because it's just multiplication by white. Beautiful, right? Now, if you can see, because all the coordinates here and in the clip space, this is basically really all these numbers that we specify here, they are just percentage of the screen. So if we resize the screen, it gets stretched, and this is very ugly. So this is yet another topic that I'm gonna do after I finally drink my tea, and I'll be right back in a minute.